Assalamu alaikum. Today we are going to start lecture number 18 for the subject of classical mechanics. We are continued with the chapter number 3 of constraints for the BS 5th and the course code of your course is PHY 509. As we have derived the Lagrange equation and there are some of the examples we have already done. Now we are going to we have to do the another example 3 and going to explain that and another example of number 4 and explaining that and solution of that examples, and at the last we have some of the references. As we are working with the applications for Lagrange equation, we have the third example, that is find the equation of particle of mass m moving freely in the space. The particle of mass m moving in the space has 3 degrees of freedom, and thus the particle has generalized coordinates, 3 generalized coordinates such that q1 is equal to x, q2 is equal to y, and q3 is equal to z. Now for the kinetic energy, we have T is equal to 1 over 2 mv square, and we know that for the x coordinate we have velocity in the x component form 1 by 2 mx dot square, and for that the potential energy is V is equal to mg8, and that will be equal to mgx. Now moving to the next step. Now L is equal to T minus V. We have L is equal to 1 over 2 mx dot square minus mgx. L is equal to, taking m common, m into n by 2x dot square minus gx. The Lagrangian equations corresponding to the generalized coordinate axis is q1x. So d by dt partial L over partial x dot minus partial L over partial x is equal to 0. From above equation we differentiate the L with the respect to x dot. So partial L over partial x dot is equal to 2 by 2 into mx dot, and partial L over partial x is equal to minus mg into dx over dx, that is equal to minus mg. So from the above equation, putting these values in the above equation, d by dt into partial L over partial x dot minus partial L over partial x, we have d by dt into mx dot plus mg is equal to 0, as minus sign makes the minus sign when multiplication equal to plus. So from here mx double dot plus mg is equal to 0 and fx plus mg is equal to 0. We know that force is equal to F is equal to ma. Here acceleration is in form of the second differential of component, so that force will be fx is equal fx plus mg is equal to 0. Taking that mg from the left hand side, on the right hand side we have fx is equal to minus mg. Now for the point q2, generalized coordinate q2 is equal to y, we are going to do the same process. T is equal to 1 by 2 mv square, and that T will be equal to 1 over 2 my dot square. So from here V is equal to mgy. So for these equations, we are going to write the Lagrange L is equal to T minus V, and going to substitute these two values. So L is equal to T minus V, and L is equal to 1 by 2 my dot square minus mgy. Taking the m common, we have L is equal to m into 1 by 2 y dot square minus gy. Now the Lagrangian equation corresponding to the generalized coordinate y is d by dt into partial L over partial y dot minus partial L over partial y is equal to 0. Doing the same process, we have partial L over partial y dot is equal to 2 by 2 my dot, and the partial L over partial y, here that x is written mistakenly, so that is partial L over partial y is equal to minus mg into dy over dy is equal to mg. We are going to substitute these values in the above equation of Lagrange equation, part d by dt into partial L over partial y dot minus partial L over partial y is equal to 0. So we have d by dt into my dot plus mg is equal to 0, and my double dot plus mg is equal to 0. We have f y is equal to my double dot, so fy plus mg is equal to 0, so fy is equal to minus mg. Now similarly we are going to do the same process, and you can do easily. Q3 is equal to z. Here the kinetic energy is 1 by 2 mv square, and that will be equal to 1 by 2 mg square, and v is equal to mgz. We are going to write the Lagrange for that coordinate. We have L is equal to T minus V. L is equal to 1 by 2 mg square minus mgz. The Lagrange equation is partial L over partial L, du L over dt into partial L over partial z dot minus partial L over partial z is equal to 0. Here d by dt into mg dot plus mg is equal to 0. Mg double dot plus mg is equal to 0. Fz plus mg is equal to 0. And here you can see that Fz is equal to minus mg. Now we are going to do another example of the Lagrange equation. Obtain the equation of motion of the single particle of mass m in the polar coordinate where the forces are acting on the particle is known. Now here we can see the figure. You can see that there is x coordinate and having the value x is equal to r cos theta, and the y coordinate in which we have a radial component r whose unit vector is ar unit vector, and transverse component a theta cap, and the vertical component of r is y is equal to r sin theta, and there is an angle theta between the horizontal component and r. Here are the two generalized coordinates. Q1 is equal to r, and q2 is equal to theta. Now going to work out that the particle m will have 2 degrees of freedom, so the general coordinates are q1 r is equal to q1 is equal to r, and q2 is equal to theta. From here we figure x is equal to r cos theta, giving that equation number A, and y is equal to r sin theta, giving that equation number B. In terms of polar coordinates, velocity v is equal to r a r unit vector plus r theta dot a theta cap, and v is equal to r dot a r unit vector plus r theta dot a theta cap, and taking a dot product between v and v, we have v dot v, so can see that r dot a r unit vector plus r theta dot a theta cap dot r dot a r unit vector plus r theta dot a theta cap. You can see that the only same components can be same components of or the unit vector can be multiplied and the other will be cancelled out, so we have v square is equal to r dot square plus r square theta dot square, and the other terms are neglected as they are equal to 0, so the t is equal to m1 1 by 2 mv square, and substituting that value of v square, that is 1 by 2 into m into r dot square plus r square theta dot square, that is written as in the equation number 6 c. As in this problem, instead of giving the potential energy, the forces of the particles are known as the Lagrange equation, that is d by dt into partial t over partial qi dot in the form of kinetic energy minus partial t over partial qj. Partial qj is equal to capital Qj. Here L is equal to T minus V, and potential energy not given, so L is equal to T. Here Qj is equal to summation I Fi dot partial Ri over partial Qj. So as we have the single particle, so Qj is equal to F dot partial R unit vector over partial Qj. As there are two generalized coordinates, so there will be two expressions for qj, that is qr is equal to q theta. For qr is equal to f dot partial r vector over partial r magnitude is equal to f dot partial over partial r into xi cap plus yg cap, f dot partial x over partial r I cap plus partial y over partial r. Substituting the values, f is into f into partial r cos theta over partial r I cap plus partial r sin theta over partial r j cap. We have f dot into cos theta I cap plus sin theta j cap. Here f qr is equal to f dot ar unit vector is equal to f of r, giving that equation number A. As qr is the radial component of force, so now for the transverse component, q theta will be equal to f dot partial r over partial theta. Substituting the values, we have f dot partial over partial theta x I cap plus yj cap, and we have f dot into partial x over partial theta I cap plus partial y over partial theta j cap. q theta is equal to f dot into partial r cos theta or partial theta I cap plus partial r sin theta or partial theta j cap. Differentiating with respect to theta, we have q theta is equal to f dot into minus r sin theta I cap as differential of cos theta is sin theta. So minus sin theta was substituted, and I cap plus r cos theta j cap as the differential of sin theta is cos theta. So taking the r constant, r common, we have q theta is equal to r f into minus sin theta I cap plus cos theta j cap. And from here you can see that sin theta I cap plus cos theta j cap is the transverse component of the force F theta. So we have can write q theta is equal to rf dot a theta cap minus is equal to rf theta, that is equation number B. From here you can see that q theta is equal to rf, that is the transverse component of the force. The Lagrange equation corresponding to the generalized coordinate are d by dt into partial t or partial r minus r dot minus partial t or partial r is equal to qr. Giving that equation number A, we have partial t or partial r dot is equal to partial over partial r dot into 1 by 2 mr dot square, that will be equal to 2 by 2 mr dot. So the equation is mt over partial t over partial r dot is equal to mr dot. Giving that equation number 1, partial t or partial r is equal to partial over partial r into 1 by 2 mr square theta dot square. Partial t or partial r into 2 by 2 mr theta dot square. Cancelling the two terms, 2 by 2 we have partial t or partial r is equal to mr theta dot square, and giving that equation number 2. Now putting these values in equation A, we have d by dt into mr dot minus mr theta dot square is equal to f of r. Mr double dot minus mr theta dot square is equal to f of r. Here you can see that mr double dot minus r theta dot square is f of r, radial component of force we have already discussed previously. Now generalized coordinates theta d by dt into partial t or partial theta dot minus partial t or partial theta is equal to q theta. Giving that equation number B, partial t or partial theta is equal to 1 by 2 into 2 mr theta dot 2 mr square theta dot, and partial r over partial theta in the above equation will be equal to 0, as there is no term with respect to theta that can be differentiated with respect to theta. Putting these values in equation B, we have d by dt mr square theta dot is equal to r of theta, that is the transfer component of the force. Giving that equation number C, we can see that L is equal to mr square theta dot. So from here d by dt into L is equal to r of theta dot, and giving that equation number D, that is the result for that we have discussed in this example to solve out. Till here you have already understood the topic. If there is any difficulty in the understanding of the mathematical work, you can ask me. Thank you. Here are the similar references you are already discussed about the books, you can follow. Thank you. Allah Hafiz.